Hey guys, we are now on chapter 3.2, which is about complex numbers. So think about your algebraic life so far, right? Like last chapter, or last section, chapter 3.1. When you did some of the problems and you were about to be required to square root a negative number, right? When you take the square root of both sides and you put a square root over a negative number, you say, wait a minute, I can't do that. There's no real solution to that, right? However, guys, could there be another type of solution that is not a real solution? So here is the cool kind of sci-fi parallel world situation. There's another type of number called a complex number. And part of a complex number is what we call an imaginary number. Now, before you get stressed out and say, oh no, I have to learn a whole new world of numbers. The good thing that it is about imaginary numbers and complex numbers is that they actually operate very similarly to the world of real numbers. So everything you've learned in algebra is actually going to apply and you'll be able to use it in the world of imaginary numbers. So in this world of imaginary numbers, we actually can take the square root of a negative number. So let's think about this for a sec. What's the no-no in the real world? Well, if I have a square root of a negative number, I'm basically taking that number and multiplying it by -1. So this is the no-no right here in the world of real numbers. So what we've done is we've created, right, an equivalent that represents the square root of a -1, and that's called I. It's nice that they called it I because I is the first letter of imaginary, so that's kind of nice. Okay, so just like I said, we can do a lot of the same things in the imaginary world that we can in the real world. So what I can do in the imaginary world and the real world is square both sides of the equation. So if I square both sides, well, let's think about it. What happens if I square something that's square rooted? Well, if I square something that's square rooted, it just turns to the number itself. And if I square that, I get I squared. So guys, this is a very important thing, put little stars around it, that we are going to end up using in our exploration of complex numbers. That I squared equals -1. So before we get to complex numbers, let's take a look at some of the imaginary numbers and let's simplify them. So here, if I have the square root of -25, in the past I would have had to say, sorry, no real solution. But now what I can do, and this is the Brindley super duper method here, this negative sign, I'm going to pull it out and I'm going to make it an I. And now I just have the regular old square root of 25, which is 5, right? So I times 5, I'm going to use the convention I use in the real world and just put the coefficient in front. Okay guys, what if I have the square root of -7? Well, again, I'm going to take an I. And square root of 7, I can't simplify that, right? It's not a perfect square like the square root of 5. This one's going to be a little harder because, not this part, this is the same. I times the square root of 72. Now that's not a perfect square, but it can be simplified, unlike the square root of 7. So what I want to do is think about the biggest perfect square factor of 72, and that is 36, right? 36 times 2 is 72. So now this is a perfect square, so I can say I times 6 times root 2, which gives me 6I root 2. Now, the last one I was trying to be a little tricky, because this minus sign is different than this minus sign, right? This minus sign here means I. So what I have is -5I times the square root of 9. Square root of 9 we know is 3, and I can multiply it just like I would with algebra. So notice, guys, in all of these problems, we're kind of treating I like an X, like a variable. And that's what we're going to do when we get into the world of complex numbers. Complex numbers have these imaginary parts, like this, and they also have a real part. So the way standard form for a complex number is a plus bi, where a comes first, that's the real part, and bi is the imaginary part. Now the good thing is we can conduct operations with these numbers just like we do in algebra. A good way of thinking of it is we're going to treat I like x, right? Just like any variable. So if I had 8 minus I plus 5 plus 4i, if those i's were x's, what would I do? I would combine like terms. So guess what? That's what I'm going to do. I'm going to combine like terms. I've got 8 plus 5, which is 13. And I have negative I plus 4i, which is 3i. Notice my answer is in a plus bi form. Okay guys, now I have a subtraction sign, so I have one extra step. I have to distribute that minus sign. I would have to do that if I were dealing with x's as well, right? That minus sign changes this to a negative 3 and that to a 5i. So now I've got a 7 and a negative 3, which gives me 4. I've got a negative 6i plus a 5i, which gives me 1i. Okay guys, now let's distribute the negative here. I get 13 minus 2 minus 7i. Notice the negative sign doesn't hit that last 5i. It's not in the parentheses. So again, I've got 13 minus 2, which is 11. And I've got negative 7i plus 5i, which is negative 2i. So notice all of my answers here are in the form a plus bi. Nothing super earth-shattering, right? We're just using our skills at combining like terms. Okay guys, let's spice it up a little. We are going to now multiply complex numbers. Again, we're going to use a lot of the same methods as we do when there's an x. So let's take here, if I see something in front of a parentheses, what I'm going to do is I'm going to distribute. So 4i times negative 6, negative 24i plus 4i squared. Okay guys, here's the big moment. A plus bi, that doesn't have an I squared. What am I going to do with that? Well, if you guys remember, I have this equivalency here. We know that I squared is equal to negative 1. So watch what I'm going to do here. I am going to replace I squared with negative 1. So let's see what we have there. We replace I squared with negative 1. We have negative 24i plus 4. And then instead of I squared, I'm going to put a negative 1. So look what happens here. I have negative 24i minus 4, but it's traditional that we put the real part first. So that is what I end up with. Every complex number is going to simplify to the form a plus bi. Okay guys, what would I do if those were x's? What I would do is I would FOIL it. And guess what? That's what I'm going to do. FOIL means first 9 times negative 4, which is negative 36. Outer 9 times 7i, which is 63i. Inner negative 2i times negative 4 is 8i. And last, negative 14i squared. Right? FOIL has 4 parts. So before I start dealing with the I squared, let's combine like terms here. So I've got negative 36 plus 71i minus 14i squared. And just like we did in the problem right before, we are going to replace I squared with negative 1. So that means I'm going to have negative 36 plus 71i minus 14. And then, instead of I squared, I'm going to write a negative 1. Okay, guys, let's start simplifying this. I have negative 36 plus 71i plus 14, right? Because the negative. And that ends up with, these are like terms, negative 22 plus 71i. That's what I've got. Okay, guys, everyone's tempted here to just square the 3 and square the minus 2i, but we know that's not what quantity 3 minus 2i squared means. What it means is 3 minus 2i times 3 minus 2i. So let's FOIL this. We have to FOIL it. So 3 times 3 is 9. 3 times negative 2i is minus 6i. Negative 2i times 3 is also minus 6i. And negative 2i times negative 2i is plus 4i squared. Okay, guys, I squared, we know, is equal to negative 1. So I'm going to say 9, and this becomes minus 12i, and this becomes plus 4 times negative 1. Right? So that gives me 9 minus 12i minus 4, which I can simplify, because 9 minus 4 is 5. So I can simplify that to 5 minus 12i. Notice they're all in a plus bi form. All right, guys, we're going to move to the next board. This is super quick. We're almost done. Okay, guys, so now that you know about the world of complex numbers, when you solve an equation where you have to square root of negative, you no longer have to say, no can do, Miss Brindley, no real solution. We don't have to do that anymore, right? So let's just have this amazing beauty of math moment now that our world is opened up to complex numbers. You may have seen this exact problem, in fact. Okay, so I want to use square roots here. So what I'm going to do is I'm going to isolate the squared term, just like I did last section. So that means I'm going to isolate x squared. So let's subtract 4, and I get x squared equals negative 4. At this point we would have said no real solution, right, guys? If I square root both sides, remember when I'm solving an equation, when you solve an equation, you need both the positive and negative roots. So when I take the square root of negative 4, that's actually going to be plus or minus I root 4, and over here I'm going to have x. Right? I'm going to take that out, make it an I. Okay, guys, the square root of 4 is a perfect square, so I can say x equals plus or minus 2i. Now, you may wonder, does that show up on a graph? And the answer is no. We're going to be exploring that later on this unit. Okay, guys, let's do the same thing here. We're going to isolate the x squared. That's where we're isolating. So let's add the 11. I get 2x squared equals negative 36. And then let's divide both sides by 2. We don't want to square root until it's divided by 2, till the x squared is completely alone. Okay, guys, in the past we would have had to say no can do, but not now. Now we're going to square root both sides, and we're going to say, oh, look, that negative sign can come out and become an I. Right, so I've got x equals plus or minus I square root 18. Well, root 18 isn't a perfect square, but it can be reduced, simplified. If I think of the biggest perfect square factor of 18, it's 9. So I can say I square root 9 square root 2, and that gives me x equals, square root of 9 is 3, right, guys? Plus or minus 3i square root 2. So now I can solve those equations. Yay! Okay guys, this parallels the last units, our last problem. Remember, when they ask you to find the zeros of a function, you are going to make f of x equal to 0 and solve for x. Okay, so let's make f of x equal to 0. 0 equals 4x squared plus 20. And now let's solve this equation. Well, I want to isolate the squared term, which in this case is the x squared, right? Guys, I want to isolate that. So I'm going to subtract the 20. So I get negative 20 equals 4x squared. Square term isn't isolated yet. The 4 is in front of there. So I'm going to divide both sides by 4. And I get negative 5 equals x squared. So let's come over here. Negative 5 equals x squared. Now I'm going to square root both sides. Right? And again, over here, I'm going to take that out and make it an I. So I get plus or minus I square root 5. And on this side, I get x. And then I check to see, can that be simplified? The answer is absolutely no. So guess what? I am done. All right, guys. Thank you very much for listening to my video, and I will see you soon.